Okay, back. This is part 3 of it. My recorder keeps stopping on me, and I left my software to put it together at school, so I'll just put it in pieces and give it to you in pieces. Okay, so what's the domain and the range? Remember, domain is always left and right, the way we graph. And so where could the x's be? They're the x's. Okay, notice that ends right there. It ends right there. It doesn't go over here. We'll talk later about why it doesn't, but square root of negative numbers just, it doesn't work. Okay, we already know that. What could x be? X could be 0 or any number that's bigger than 0. So here, the domain would be x is greater than or equal to 0 because it's not going to cross into negative land. What about the range? Remember, y is the range, and it's going up and down. Where could it be? Okay, well, it can't be negative because that would be take the square root of something and get a negative number. We don't do that. Right, dog? Dog is saying, well, I don't know what you're saying. You really think that? Huh? Froggy says, Froggy comes over and says, Doggy, because Doggy is wondering, and tells him, hey, Froggy, guess what? You can't do it. Square root of a negative number doesn't work. Froggy says to Doggy. Doggy says, are you sure? Froggy says, yes, except in Algebra 2 it will work. It'll be magic in Algebra 2. But for right now, in Algebra 1, no such thing as a square root of a negative number. But notice that's subject to change. Okay. So, domain. X is greater than or equal to 0. What could y be? It's not going negative because this is Algebra 1. We're not going to learn about the other till Algebra 2. Okay, so it can't be negative. So it's got to be the up and down. It can't go below 0, and it can keep on going up. So the range here is going to be y is greater than or equal to 0, just like that. Okay? So what's this going to look like? Let's look at a few of them and see what happens. So here's one that I just talked about. Okay? Here's the parent function, y equals the square root of x. Notice what happens when we graph 3 times the square root of it. It gets stretched. It's higher up. It goes more steeply. Okay, let's look what happens at this one. Y equals the square root of x, but we multiply it by a number that's smaller than 1. You notice that the red doesn't go down as fast as the blue goes up. And since it's multiplied by a negative number, it's a flip. You say, wait, Frog, I told you you could have negative. No, you can't. Okay? This is negative after you do the square root. It's not negative inside the square root. So what it does is it just reflects it across the axis. And that's an okay thing to do. Let's look at other things that happen. Okay? So how about this one? Okay, this one is going to be y equals the square root of x. There's the parent. But then after you do the square root of 2, the square root of x, just every one of them you add 2 to it. Well, I think you figured out because you've done lines and you've done parabolas, and you can figure out the whole thing's just going to shift up 2. It's the same shape, but it's up 2. Oh, look, the intercept is 2. How convenient. Just like on the other types of functions that we've done. Okay, so here we've got our 2, and it's up 2 all the way. And they're going to stay together just like that. So when we add a number outside of the radical, that just becomes our y-intercept. Okay? Well, what happens if we add a number inside the radical? If we put a number inside the radical, let's look at this one and see what happens. Okay, this is the square root of x, and this is the square root of x minus 4. That's all under the radical. That's all square root of x minus 4. It's not separate. Okay, so well, first off, notice that x can't be less than 4, because 4 minus 4 is 0, and you can't go negative with the square root, despite what Doggy wants to say. But Froggy's real sure about it because this is Algebra 1. In Algebra 1, you can't have the square root of a negative number. Well, look what happened. This said x minus 4. Look where our graph ends. It ends at x equals 4. That's a minus 4, that's a plus 4. Well, that's pretty interesting. Okay. Oh, that's Ollie. Do you hear Ollie? Yeah. Ollie needs to hush. Ollie? You okay, boy? Okay. So, this one is going to be like, remember the point-slope form? The point-slope form, sorry. In the point-slope form, all of the ones were negative and you had to switch it around. That's the same here for the x. Now, not for the y, but it is the same for the x. And so what we're going to come up with here is a standard form of a radical, and it's going to look like this, a radical function, a square root function. It'll be y equals, where's my thing? There it is. Y equals some number a times the square root of x minus h. Oops, and that's too long. So I'll rewrite it. Y equals a times the square root of x minus h. I wrote it too long. Plus k. So what we have here is that once we've done that, we can tell where it ends. Remember we had these and we wanted to know where it ends? Because it's going to kind of follow this shape. It'll just be stretched or shrunk. We need to know where to start drawing and kind of how stretched or shrunk to get it. So this will tell us, the minus 4 tells us to go over plus 4. The x's are backwards. I know that's a pain, but the x's are backwards. Okay. And then we just kind of draw it characteristic. If it's got a coefficient out in front, if it's a fraction, it gets flatter. And if it's a number bigger than 1, then it gets taller and stretched. So what we have here is that h is the x value and k is the y value of the starting point. Okay? But since it's special, and I don't know why other than that, but we just go ahead and call it h and k, because that way we can distinguish it from the x's and the y's, just to be doing it. We could call it x sub 1 and y sub 1, but that tends to mean any point on the line, and this one's not any point. It's the specific point where it starts. It's h and k, and once you get to geometry and algebra 2, h and k will be used for a whole lot of things. You remember we used it for the vertex anyway. And so it's good to get used to thinking about h and k as the x and the y value. So again, this is our form of a radical equation. We can tell from that how to graph it. So if I had y equals 2 times the square root of x minus 3 plus 4, how am I going to graph that? Here's what I'll do. Okay, so where am I going to start? Okay, well, 3, not negative 3. 3 is how far to go on the x, and 4 is how far to go on the y. So this is where I'm going to start. This is not a negative, so it's going to be the usual curve going up. If it were a negative outside, then it would be the same mirror image of the curve going down, but it's not. Okay, the standard one would look about like this. I'm just kind of roughing it out. It'd look about like this. So this one's going to be stretched because there's a 2 to multiply it by, so it's going to look more like this. So then that's what our function is going to look like. Now, when we're drawing it, I'm not going to usually ask you to draw it more accurately than that. If I did, then what you would do is just, do your t-chart and and do your X's and Y's and make sure you get a couple of points to make sure how big it's supposed to be. And actually that's probably a good idea right now to be doing that, just to see how big it is. Okay. Let's look at the domain and the range of this one.